Hi, so we're continuing down the FSL pipeline, and today I want to step you through some of the files that Feat creates. I'm not going to know what all of them are, but I'll point out the important ones and the ones that I use most frequently. Especially important is one of the files I'll point out is basically the file we edit to script the level 1 analyses for the rest of the subjects and runs. So we're going to go on a little tour. This link, if you go to this link, I'll put a copy of the link in the information box. Has a lot of information about the files. So it has this kind of setup. You can see the design.fsf. That's the big one. That's everything that's in the Feat GUI right there. And some of basically this is picking out the really important ones, and more importantly, it's helping you explain where certain things come from. We won't have this directory yet, but anyway, okay. And we won't have this because we didn't run TS plots, but the rest of it we did. So I'm gonna go to my Feat directory. Yeah, it's kind of annoying. I was halfway through recording this and realized that I had some papers from Editorial Work open on my desktop. So this is take two. Okay, so basically, tons of files here, a couple of directories. My thing doesn't highlight directories and files differently, but let's see, we can go through some of these. So I'm going to go alphabetically. So account found evs.txt, that is going to be empty here because for this subject, I didn't have any. So that corresponds to, in the stats tab, where we did the select count found evs text file, and we added the file here that was the output from FSL motion outliers. So this is just a bunch of dummy regressors modeling out bad TRs. And if you recall, at least for this subject, most of the subjects in this DS008 dataset, they didn't have outliers because they're not little kids, they're not old, they're like 20 and 30-year-olds, and they tend to be pretty good about their motion. So not everybody will have anything in there, but it creates a copy of the file. So this will only be here if you put something here. We did put something here. It was an empty something, but it was something, so there's a copy of it. The design.con is a text version of the contrast that you made. So there's always this header information in both the design.con and the design.mat, which is the design matrix. So I like to read these into MATLAB or R sometimes, and I simply tell it, to skip the first. So see, for the con, you'd have to skip 1, 2, 3, 4, 5, 6, 7, 8 lines, and then tell it to start reading, and you'll get the contrasts. The design.mat is 5. 1, 2, 3, 4, 5. You skip 5 lines, and then your design matrix is there. So that's really cool. If you need to do something else or investigate your design matrix, I often, if I'm worried about collinearity, I'll read this into R and run a quick variance inflation calculation so I have a better idea about my collinearity. Let's see, there's also, I'm going to skip over design.min. The design.png says all the PNG files in here are going to be great for our QA step. And we're going to do the QA after we actually run all the first levels, because it's more efficient to check them all at once, and we don't use more. If you're on a Mac, you can just type open design.png, if you can type it. Wow. And if you're in Linux, I always use, I think it's display. I have no idea if that's the greatest option or not. So anyway, if you need to review your design matrix or something's amiss with your results and you think you mess something up in the design matrix, you can have a look. All right, so that looks good, and then you can see the contrast in it again too. So I look back at this all the time because I'll be looking at somebody's group level analysis and be like, what was COPE 1, which stands for contrastive parameter estimates. We'll get there. And I work my way backwards to this file and I say, oh, it was stop successful minus go. Yay. Oh, and I skipped this. This is a directory, custom timing files. That has within it copies of your EVs. So these are the 3 column onset files that you input. There's just a copy of them here, which is great. Moving along, there's another PNG, which is helpful for assessing collinearity. So again, and I've talked about this before, you want this matrix over here to be bright white on the diagonal and black on the off diagonal. It's okay if it has a little bit of gray. The brighter it is, that means the higher the correlation between those regressors. These are eigenvalues, I believe, or scaled eigenvalues, and the idea is for these to be all bright if possible. I find that it typically goes dim pretty quickly. Just ignore this. Maybe someday I'll do a thing on calculating percent signal change and why I have a little bit of issue with how this is done, because it uses the regressor height in the computation, and I don't find the regressor height to be very interpretable, especially in a design like this, a stop signal task, because you can have some subjects with tons of go or with tons of successful stops and some with very few. And anyway, we'll get there. But the rest of this is helpful. If you need to do an efficiency study, I mean, if this is, so I've had people email me and they're using this to run an efficiency study. And I typically tell them, you know what, you could just code it yourself. And if I did an efficiency video before, I have to go check. I've done so many, I'm starting to lose track, that I will link to it right here. So look for that. So I would code it myself instead of using this. It'll be a lot faster to code it yourself too. And it's not like, oh, you know, somebody so dumb, why'd they do it this way? It's really hard to automate something that's going to work with anybody's design and be completely bulletproof to anything you might think to throw at it. So that's really all it is. So it's how making software works. Okay, the example func. This is the middle time point of your time series data. So we can open this quickly in FSL view. So this was used in the image registration, so it always opens this time series thing. It kind of drives me bonkers. But yeah, so this is just a 1D, I'm sorry, it's not a 1D file. It's lying, it thinks it's a 4D file. This is a 3D file, and it's just the middle time point of the data. It's not registered or anything, it's not smoothed. And this is used in the image registration. So if your image registration went amiss, have a look-see at this guy. I've actually never had to do that. Now the filtered func data is kind of awesome because this is your data after. The filtered func data file is my favorite file in any level analysis. Okay, so basically it's your data after everything here has been run. McFlirt has been run, brain extraction has been run, the data have been spatially smoothed, and the data have been high-pass filtered. And other things that they wouldn't put here because it just gets done under the hood, like the scaling, so that everybody can be compared to each other, not intensity normalization, the other grand mean scaling. I think they explain it in this help bubble here. Yeah, so if I can't move the cursor to it, but about halfway down it says, when this step is not carried out, the whole 4D data is still normalized by a single scaling factor, grand mean scaling. Each value is scaled by the same amount. So this is so that higher level analyses are valid. So that gets done, and that has been done. So if I want to do any type of analysis on data myself, and I don't even want to feed analysis, I often will still run one or just run the pre-stats so I can get this nice file where everything's scaled. And, oh my, I'm a goner. I'm never going to find that window again. Here, that's because FSL view's here. So anyway, that's just the data. Over here, I guess I could tell you what this is here. So I actually don't use this, and maybe I should use it more. I don't know. As you click around, the time series changes, and you're getting a picture of the data in red and the fitted model in blue. And then you can change this so it's just like one regressor is fit at a time, I guess. Anyway, I don't want to play around with that too long. So really handy. In higher level analyses, this is just always your dependent variable. This is always the y in the model. So if it's a higher level analysis, this will be a nice 4D file with all your subjects put together. Super handy. Okay, The logs file, I typically only go there when things go wrong. There's a mask. The MC directory, that's where the McFlirt files are, so the motion correction. And there are some files here, the rotation parameters, the translation parameters, the pre-filtered func mcf.par. Anyway, all of these are files that we're going to consider when we're doing our QA. Although we've already looked at motion pretty well by now if we've looked at the FSL motion outlier QA step. There's the mean func. This is just the average of the functional data, and then the reg directory. So the reg directory has a ton in it. I ran nonlinear registration, so this has anything I would need ever to register everything currently. All the subject analyses so far are in subject space or scanner space. Nothing's been registered, but all of the registration parameters have been estimated. So again, registration has not been applied. Once it is applied, there will be another directory in this directory, and it will have most of the files you would need in standard space. So this is everything you need to, again, we're going to use these PNGs to assess the registration. And if you needed to carry out the registration, there is example, yes, this example func to standard warp in this case would be what I would use since I used a nonlinear registration. And that has everything wrapped into it. And likewise, if you have to go backwards, if you have to go from M&I space back to subject space, you would use the files in here to do that. It's all estimated for you. A lot of them go backwards, except that I don't think the inverse warp has been, I don't see it in here. There's no standard to example func warp. Yeah, so if you needed to go from standard space to subject space with nonlinear, you would have to compute that warp. Okay, anyway, all the registration information is in here. Oops, you will not have this directory. This is only because I've already run higher level analyses. I've run them all. I've analyzed the whole data set. I haven't looked at the group analysis yet, but this, well, we can look at it. Again, you will not have, well, I keep using more. Okay. This just has the example func, the mask, the mean func, and then in the reg directory, the high res, all the files in here. Oops. These are the good ones. These are all going to be in standard space. Whereas the main file, and again, you're not going to have these unless you've run your level 2 analysis. These HTML reports are great. So let's just open up the main one. It's like I'm wearing mittens while typing. Okay, so the log, this is where you want to look for all of your errors that might have occurred, and you should be checking this log even if files were created and you think everything ran okay. Post stats, I'm not going to have anything. If you thresholded your stats, you'd have stuff here. Stats, this is going to be an overview of the model. So these are all the PNGs we're just looking at. But going through, clicking through, it's bad enough that you're going to have to click through here to look at the log. So we'll do other things. Pre-stats, here's the McFlirt stuff. And then the image registration is probably the most important one. There are all these assessments for the image registration. So you'll want to go through this to make sure everything's okay. This happens frequently. You get this mohawking for the registration from the high res to the standard. Again, the outline here is the M&I. The outline here is for the brain here, and the outline here is for the brain here. So this is the subject's brain. The outline is the M&I. And basically, the mohawking happens if there's a teeny bit of skull and McFlirt is applied, or I'm sorry, the nonlinear registration is applied, you can get this mohawking. And it'll obviously then translate to your functional data. It happens. I don't think it interferes with the analysis. If I'm wrong and you know this definitively, let me know. I've been looking at this problem forever. You can try to skull strip better. I mean, it looks like maybe I could have done a better job, but I know the algorithm used to skull strip these was pretty good. I'm almost positive free surfer was used. So that's what causes it. Yeah, if you disagree with me that this isn't a problem, let me know. I've been seeing it for years, and yeah. Anyway, we will go over that more later. Back to the tour. So we just basically went through all these HTML files. So let's go into the stats directory. Now here's everything. These COPE files, that stands for contrast of parameter estimates. Those are your contrast estimates. Then you're going to have, don't worry about these, a PE for each EV that you had. This is a parameter estimate. So I had 8 regressors total. Why are there 8? I only had 4 because I also had the derivatives. So there's going to be 1 for each of the derivatives. This is the residual file. You might use this if you ever, yeah, you might use this. It's just the residual from the analysis. Sigma squareds, this is the variance estimate. This will be used in the higher level analysis. I'm wrong. No, this is just the variance. It's just using this level. The varcopes go to the higher level. Anyway, smoothness, thresh AC. This is the temporal autocorrelation estimate. That is one of the bonuses of using FSL, is that they have this nice unstructured autocorrelation estimate. And here's the t-stat. Now, I would not look at t-stats because they can be misleading if you're comparing subjects with different degrees of freedom. So that's what the z-statistics are. All they do is they convert the t-stat to its p-value, and then they use that p-value to create a z-statistic, so you don't have to worry about varying degrees of freedom. And then the varcope is just the variance estimate. So if you want, you can actually recreate the t-statistic by taking the cope divided by the square root of the varcope. I would do it on the fly here, but I'm afraid I'll do it wrong. You can use the FSL maths command. Oh man, I should do a whole video on all the command line stuff that's so helpful. FSL maths is awesome. It basically allows you to do any math you could possibly think of with the nifty images. So you can add them, take the square root, you can take the mean over time, you can take the variance over time, threshold it, all sorts of stuff. Anyway, I'll get there later. But again, my point I was making is if you take the cope 1, divide it by the square root of the varcope 1, which you would have to compute, you will recreate t-stat 1. Yeah, maybe I'll put that code in the information box if you're interested in trying it out, because maybe seeing is believing, like it helps you wrap your head around the files. If you want to look at your z-stats, we didn't run thresholding because there's no reason to at a level 1. These are the z-stats. This is for the first one. I forget what it is again. You can add, I don't know if there's a BG. In this first level model, you don't have a lot of great, probably, you don't have a structural in here. Really? Okay. I'll just put the mean func. I hope that has some resolution. And then I can take my z-stat, I can turn it orange, and I can just threshold it at 2 and see what I have. Woo! I don't even know. I'm not going to begin to pretend I know brain anatomy. But anyway, if you're some sort of activation reality check you need to make at this step, this is how you do it. No need to run correction. All right, well, this is longer than I thought. So that is actually the end of the tour. Oh, I know, I didn't do that right. So poke around these files again on your own and really get to know them. You should know all these files. You should know what they are, and you should use them when you need things. Definitely the filtered func data, definitely the design.fsf, all these PNG files, you should look at all of them. And yeah, I think that's all I have for today. See if I had anything else in the slides. That's it. Thank you so much. I do appreciate all of you. I really have fun doing this, so I really appreciate that you watch these videos and interact. So please join the Facebook group, or follow on Tumblr, or follow on Twitter, or all 3. And next time we will script this puppy so we can just run them all and have a wonderful day.